Okay, good evening. Welcome to Math for Kids number 18. Today we're going to look at some more continued fractions. So today we're going to look at this continued fraction. 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2, dot, 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 all the way down forever.
Infinity.
All the way down to infinity. Okay?
Yeah.
So do you remember what we talked about yesterday with this continued fraction machine for doing the convergence?
Yep.
So we started out, we wrote the terms down, 1, 2, 3, 4, 5, 6, 7, that's probably enough. And, I didn't write that very well, let's do this. 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2. Okay? And then we write down these numbers. So here I'm just going to write 1, 2, 2, 2, 2, 2. So no matter what, I'm always just writing 2. Okay? And then we have our special trick that we do. Okay, and we write 1, 0, and 0, 1 here. So I go 1 times 1 plus 0 is 1. 1 times 0 plus 1 is 1. So there's our first convergent. What's our next convergent? How do you calculate it? Do you remember?
It's 2 times 1 times 0.
2 times 1 plus 1. So that's 3.
Yep.
And then 2 times 1 plus 0 is 2. So how do you calculate this next convergent?
2 times 3,
Yeah?
which is 6, plus 1, which is 7.
7. And then,
7 times 2.
no, 2 times 2
Which is 4.
plus 1, which is,
5.
okay. Now calculate the next one. 2 times 7.
14. Plus 3
3.
is 17.
17. 2 times 5 plus 2.
And it's 12.
12. 2 times 17. Oh, now these are getting tricky.
Ooh! 34
Okay, 34 plus 7 is
is 41.
41. 2 times 12
Is 24.
plus 5,
Is 29.
29. Very good. Alright, 2 more to go. 2 times 41
82
plus 17,
is 99.
99. Okay. 2 times 29
Is 58.
plus 12,
6. That's 58 plus 12 is 70.
70. Okay, very good. Actually, let's just stop here. That's enough. So, but we could keep going forever, by the way. We could just keep calculating these. And so yesterday, remember I showed you there was something neat about the Fibonacci numbers, and something neat about other continued fractions, that when you do our cross multiplying, I do 1 times 2 minus 1 times 3. In this case, I get 2 minus 3, which is minus 1. 3 times 5 minus 2 times 7, which equals 15 minus 14, so that's 1. 7 times 12, ooh, do you know what that is?
No.
It's 84. Minus 5 times 17, you should probably be able to figure out what 5 times 17 is.
Well, it's going to equal minus 1.
This is going to equal minus 1, but what's 5 times 17?
85.
85, so 84 minus 85 is minus 1. And then we keep going. But these numbers, our convergence here even have a more interesting property. So here I have bottom, or top, bottom squared. Okay, so now I'm going to look at the top and the bottom squared. Actually, let me make sure I write it in the same line. Top, bottom squared. Okay, so the top is 1 and the bottom is 1 squared. So 1 squared is?
1.
Okay. Top is, I forgot what he was doing. We're going to do top squared and bottom squared. Didn't matter for 1 over 1. What's the top squared here? What's 3 squared?
Is 9.
What's the bottom squared?
Is 4.
Okay. What's the top squared?
49.
49. Bottom squared is 25.
Yep.
Okay. 17 squared is 289. The bottom squared, do you know what 12 squared is?
144.
144, very good.
Can the camera see that? Yep.
They should be able to. Oh, and I'm drifting a little bit. 41 squared. Ooh, I bet you know what 41 squared is, don't you?
41 times 41.
Yeah.
I don't.
Remember, it's 40 plus 1 squared?
Oh yeah.
40 plus 1 squared, which is 40 squared, plus 2 times 40 plus 1.
Which is, so for 40 squared is 40 times 40, which so it's 40 squared plus 2, it's 40 squared plus 80 and plus 1.
Yeah, so that's 1681.
Yep.
And 29 squared. We can actually do the same trick for 29 squared. We do 30 minus 1 squared, which is 30 squared, minus
2 times 30.
2 times 30 plus 1. So it's slightly different. 30 squared is 900. 900 minus 60 is?
Is 830.
Or
No.
8, what, 900
40.
minus 60 is 840 plus 1, so this is 841. And then we'll do 99 squared. It turns out to be, we use the same trick. 99 squared is 100 minus 1 squared, which is 100 squared. You remember what 100 squared is?
It's 10,000.
10,000 minus 200 plus 1. What's 10,000 minus 200?
It's 9,800.
So this is 9,801. And 70 squared is just 4,900. Okay?
Awesome.
Now there's an interesting relationship between these numbers.
I'm just going to draw a line through them so we can...
Okay? Now I want to add one more line, which is 2 times the bottom squared. Okay? What's 2 times 1?
It is just 2.
2. 2 times 4 is?
2 times 4 is 8.
2 times 25 is?
Is 50.
2 times 144.
Is 288.
288. 2 times 841.
Is 1682.
1682. 2 times 4,900.
9,800.
9,800. Very good. Okay, now let's look at the top squared and look at the bottom squared. 1 and 2, so this is, the bottom is plus 1. 9 and 8, the bottom is minus 1. 49 and 50,
Bottom is plus 1.
bottom is plus 1.
Plus 1 minus 1 plus...
Minus 1, plus 1, minus 1. Isn't that interesting?
And then...
Whoa, careful.
I think, well, we think the next one's going to be plus 1.
We think the next one's going to be plus 1. Okay? So these,
But I think it's a little off camera.
that's alright. These numbers have a really interesting property, or convergence have a really interesting property. And the property is that when you square the top and you square the bottom and multiply the bottom by 2, you almost get the same number. You get 1 and 2, 9 and 8, 49 and 50, 289, 288. They're always off by 1. Isn't that amazing?
Yeah, but they're off by 1 in different ways.
Yeah, they're off by 1 in different ways, but they're off by 1 in pretty consistent ways, actually.
Yeah.
So this is a continued fraction. Our continued fraction that we're studying here is a continued fraction for something called the square root of 2.
Whoa.
Well, and that the square root of 2 is written like this, and we've never talked about this before.
I have not talked about that, the V with the line.
The v with the line, yeah, we've never talked about that. That means square root. So our continued fraction,
The machine goes bye-bye.
yeah, our continued fraction 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2, all the way for infinity. This equals something called the square root of 2. And the square root of 2 is a number that has the property that the square root of 2 times the square root of 2 equals 2. Okay? So we don't know about numbers that have this funny property. We know about 1 squared is 1 and 2 squared is 4. But the square root of 2 is a funny number and has the property that the square root of 2 times the square root of 2 is 2. Can you even imagine what kind of number that must be like? Must be a pretty strange number.
Must be a pretty strange. I wonder what the number in numbers is.
I wonder what the number in numbers is. It's about 1.41 something. I'm not exactly sure. I don't remember. Okay. So that's what this really easy to write down number 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 equals this really funny number, the square root of 2.
Is there like a square root of 3 and square root of 4 and square root of 5?
Yeah, there is. The square root of 4 is just some number. The square root of 4 times the square root of 4 just equals 4. Can you think of two numbers that when you multiply them together you get 4?
2.
2. So the square root of 4
Is 2.
is 2, but it can also equal minus 2. Because minus 2 times minus 2 is 4. So you have to be careful with square roots.
You have to be a little
You
careful.
have to be a little careful if you're talking about the positive ones or the negative ones. So I just thought I'd show you this. This is pretty neat. And these numbers here are really good approximations to the square root of 2. Okay? What do you think about that? Yay!
Mr. Smiley Face 2 comes in again.
Alright. Good job tonight, honey. Good
Awesome!
job.